There you go, you're live.
Hello, everyone. Okay, now welcome back, and this is Aaron for his talk.
And the reason Hannah's talking is because I need this for my throat. Aaron, can you say Aaron, over to you?
Oh, Aaron, over to you.
Thank you. I will just set up the screen share. Alrighty then. So we've got this awkward thing of I'm not sure if my screen is shared properly because I can see the video in the other screen and it's not started up yet, but that could be just because it's like a minute delay.
It's working fine.
I know it's
all
working
good.
fine. I'm building suspense, Richard. Damn. There goes that suspense. Anyway, so yes, I am Aaron. I am here tonight to talk to you about React and whether or not it is just another JavaScript UI framework. So React's been gaining a bit of popularity of recent. It's from Facebook. It's Facebook's answer to doing modern web application development in JavaScript. So like your Angulars, your Backbones, etc. But this one's from Facebook because everyone needs to build a new one. The thing I want to talk is whether or not it's something that should be interesting. It should be something you can look at, and whether and basically give you an idea whether you might want to have a look further into it. And you might be already using Angular, stuff like that. I'm actually going to be fairly light on slides tonight because I mostly want to dive into code because I think that's going to be a better way to sort of illustrate what we're going to be going on about. So first off, let's write some JavaScript. We're our total hipster JavaScript developer. Yeah, I've got my rockin' beard. And I'm going to type out some JavaScript, and it's going to be like mad skills JavaScript. I've created a whole bunch of TRs that I'm going to put into the TD of a table because I'm updating some records based off of a response I've got back from a server. And I'm doing this with like a super shorthand method to find an element and update some HTML. It's total badass JavaScript that I'm writing right here. So we've done that, and we've updated the HTML, and the DOM goes, yeah, cool, bro. I got this. Like, I'm totally going to update these tables for you. It's going to look awesome. Like all that HTML, the users are going to love it. It's going to be rocking. The users are going to have fun. But then Brendan comes in from the side and he goes, hey, wait. I'm going to let you finish. But first off, we got to do a reflow and a repaint because you might have changed some of the position of elements on the screen. And this is going to have to like readjust the way the CSS was originally applied to the page. So things are going to move around. So like, I got to apply this shit before we can move on any further. Okay. I guess we got to kind of do this update. We don't have much control of it, so we'll wait for that. And then we get this lovely thing that happens when pages take forever. The spinning beach ball of death, or if you're on a Windows machine, whatever the weight icon is currently on Windows machines. It's a spinning circle, I think. Anyway, so we have this broken user experience because the pages all of a sudden become very sluggish. The user doesn't really understand why. They've done some kind of interaction. It's done something that's updated the information that they should see, and it's all of a sudden started slowing down and chugging really badly for them. And this is, users get sad by this. Users are likely to leave sites if they don't perform very well. There's plenty of statistics out there that will tell you how long a user will stay on your site if they're bored. So the moral of the story here is that DOM updates are expensive. This is a quote from me just now. Feel free to use it in your own talks. It's CC'd, so by all means, use this amazing quote. It's one of a kind. So given the DOM updates are expensive, we've really got to think about how we're doing DOM updates. And because ultimately what we want to do is try and minimize this sort of stuff. We want to minimize the impact on users as we do changes. So this is where we bring in the virtual DOM. Woo, magic. This is what Facebook has been touting as the exciting thing about React, the thing that kind of sets it apart from other JavaScript UI frameworks. There's a few other things that set it apart, like the fact that it is literally just the UI management. It's not a full suite of tools like you would find with Angular. It doesn't have a built-in XHR. It doesn't have a built-in promise stack. It doesn't have a built-in query engine. Angular gives you like everything in the kitchen sink. React gives you a way to put HTML on the screen. But the virtual DOM is kind of their big wow factor in it. And the idea behind it is that every time we have to query the DOM, every time we ask it what the state of it is, like what is the value of the inner HTML of this element, what CSS classes have you got, this is a slow operation because we have to break out of the JavaScript runtime. We have to hand that over to the DOM layer that the browser owns, and then that gets exposed back to the JavaScript runtime. So the more that we ask it, the more times things are likely to slow down. And this also, this is particularly bad when it comes to writes into the DOM. So the idea of the virtual DOM is you keep what the DOM looks like, or at the very least it should look like as far as React is concerned. You keep that in memory. So you know what the tree looks like, you know how things relate to each other, you know what the classes, what the additional attributes, what the inner HTML of elements should look like. So if we have that in memory, when a change occurs to the data that we're using to render out on the screen, we can look at what we think that, what we know the DOM is, what we know the new DOM is going to be, and then perform a diff on those two, work out precisely what has happened, and then only update exactly the things that have to change. Say that in the previous example where I was outputting a bunch of table rows, so really what I might have changed in that is the inner HTML of a couple of TDs inside of those table rows. So if I could just update the inner HTML of those specific TDs that changed, then I don't have to rebuild the TRs. I don't have to rebuild all the other TDs that are on that in that particular row. Other things we can do is obviously manipulate the list of classes. If I just add and remove the class without having to recreate that element from scratch, then the browser has less things to figure out. If I've got 3 classes because we're using Bootstrap and we've got button, button big, button green, and all these classes basically tell it's a button, and we change that from say the button button success to button error or button danger because we've gone from a happy state to a sad state. If we just change that single class, we don't have to change the others. The browser has less that it has to recalculate because there's only one different set of style rules that have to be applied. Ultimately, what this comes down to is we want to avoid creating elements as much as we can. The more we can reuse the existing elements on screen and just manipulate their contents, manipulate their attributes without having to recreate them, the less the DOM tree has to recalculate itself, and the less reflows and repaints that we're going to also get by a factor of that. The other thing that we really want to strive for to make this concept of a virtual DOM work is we want immutability. That's right, kids. This is very much a functional programmer's wet dream in terms of the browser. But the idea with React is that everything is immutable. In JavaScript, things technically aren't immutable because we don't have the concept of immutable objects. But we can sort of simulate it. And the way that React works, and we'll have a look at that in a moment when we get into the demos, is that we push down things as information. We push those into components, and components then do callbacks out to someone else that owns that original component. And we only ever push changes down. We don't manipulate the state of a chain of data within of ourselves. It's always someone else's job that manipulates that. We can push that change down to one or multiple different items that might be visible on screen, and the browser can be a lot more intelligent about what needs to be updated, or the framework that we're using can be a lot more intelligent about telling the browser what needs to be updated. So that's a good 8 minutes of me talking with a lovely green slide deck. Now it is time to jump over to some demo code. Woo! This is going to be somewhat of a live coding without actually writing any code. So I've got a little application here. It's very exciting. It has a lot of HTML in it. As you can see, it has an open HTML tag. It has a closed HTML tag. In between those, we have some magic elements like a head tag and a body. Inside the body, I have a single div element called app. That is the ID, and that is the only HTML that is for my application that I'm rendering in this HTML file. Instead, I am outputting some JavaScript files, jQuery, and a few other things. And at the bottom here, I've got my app min.js. So this is our minified combined JavaScript that we've got. I'm using Gulp under the hood to do this, plus some additional tooling around that. If you had been in my talk on Tuesday night, you'd know all about that, and you'd be like, Gulp, I'm like totally all over that shit. Anyway, let's start into the entry point of our application. So I have a file here in the sidebar called app.js. So this is the entry point. Now, what I've done is I've used React itself, and I've used a plugin for React called React Router, and this is a tool, a plugin for doing a page concept. So moving from page to page to page, because that's the kind of sort of thing you want to do inside of a web application, particularly if it's a single page application. The other thing that I've done here that you might be going, this isn't JavaScript that he's writing, is I'm actually using ES6 syntax through and through. That's what the import statement is. It's importing something from a dependency. Again, if you had been in my Tuesday talk, you'd have heard all about this. Exciting stuff. I'm also using some other ES6 stuff like the const keyword, just to define a constant object and stuff like that. But you will start noticing things that are going to be very scary to a lot of people that are coming to React for the first time, and that is angle brackets inside of my JavaScript, and that is not for a greater than or less than symbol. That's right, this is very much like writing HTML inside of JavaScript. And before you turn off the screencast and like throw your laptop against the wall and go, why would you write HTML inside of your JavaScript? I want to actually just pause on that fact, because this is something that a lot of people find very confronting when they first come to React, is this concept of JSX, which is the syntax of writing these angle brackety sorts of things inside of our JavaScript. People look at that initially, and I'm not going to lie, I looked at it initially and dismissed React because I'm like, well, why would I write HTML inside of my JavaScript? But what I stopped and thought about was, if we treat what React is doing as purely UI management, so it is purely updating the DOM, or this particular snippet here is defining my navigation paths. It's purely a view concept. That's all React cares about. You give it data. Where that data comes from is entirely up to you. You just have a view and you're outputting that. This can be very much akin to what we do with, say, Razor in ASP.NET MVC, or if you're doing rich desktop applications like WPF. We have a syntax that is used to define a UI construct, and we have some sort of scripting language around that that will modify the data that we've provided to the view and output that in the appropriate format. Basically, what we're talking about is templating. It's really just a bit more of an advanced templating engine around what you're writing your HTML at the end of the day. Yeah, in one way to think about it, which once I kind of looked at it like that, because we've all written a for each loop inside of our Razor file because we're building out a navigation system. We've probably written an if statement inside of a Razor file because we had some conditional logic that we had to check. Those sorts of things are not like, you're not going to freak out because you're writing C# inside of HTML. You know, that's exactly what I would always be doing. That's just totally natural. And the similar approach here with React. So that's why I actually don't find JSX as confronting anymore as when I initially did. Anyway, back to what this application is doing. If people haven't worked it out yet, it's a chat application. It has 2 pages. It has a login page and it has a page. Yeah, 2 pages. So with React Router, I'm importing a couple of dependencies. So the router itself, so route definition helpers, the route, a default route, and then I'm going to use HTML5 history push state. So we get nice URLs, not hash-banged URLs. I'm defining some routes. I give it a handler where is the start of my application, and then a couple of pages that we're going to be transitioning through. I then tell React Router that to use these routes, set yourself up, use this history handler, and then React, you'll render the handler into a particular element on screen, which is our app ID'd div. So let's dive into some of these views. Yeah, we'll dive into the replay view. So this is the first entry point to the application. It's pretty simple, and this is where we start seeing more HTML getting written out to the screen. Written out inside of JavaScript. I've got some div tags. I'm using Bootstrap because I was too lazy to write CSS for this, and I wanted it to look like every other friggin' website on the web. So it's using Bootstrap. I'm outputting a nav bar, and then at the end, I'm doing a route handler. That's down here on line 17. The route handler is what React Router uses to do page-to-page navigation. it will replace this particular section of the screen with the page that I've just navigated to. So my nav bar is going to be constant and the body of the page changes, basically. So let's jump through to, say, a home page. Actually, no, I'll start with the login page. This is an ES6 class. That's where the class syntax. Extending the base React component. Everything in React starts from a React component, so inherit from that, so I can expose it then to React. We get properties that are passed into a React component. So properties are things that I'm passing down, information, handlers that we can call back, that sort of stuff. It's always stuff that's passed in, and that stuff is immutable. Anything that is in your properties collection for a React component is immutable in the component that its properties. It might actually come from state higher up in your hierarchy, but it's immutable in, say, this login control. Anything that's on the props object is immutable. I can set up local state, and there are scenarios where you will want to set up local state, and that's what I'm doing on line 12 of this.state equals an object. The login screen obviously takes a username. This is not super secure, so you don't even have to put in a password. Excellent. So I set up just a state that's going to have a username that is undefined at the moment because you haven't defined anything. I've got some callback handlers that are being bound to this being the instance of the login component. That's just so that we don't have, this handling gets all weird inside of JavaScript if you don't properly understand and control how this works. We have a couple of backend services. I'll talk about those in just a moment. We'll come down to our render method first, though. So the render method is the most critical method inside of a React component, and it's the only method you actually have to implement in a React component. Render is what returns HTML to the screen, or what returns React components to React to then ultimately turn into HTML. What I'm doing here is I'm returning, I've got a wrapper around Bootstrap called React Bootstrap, and I'm returning a modal dialog that becomes a Bootstrap modal dialog. Inside of that, we've got a modal body, a modal footer, and we build up some HTML, we return that, and then that gets put into the virtual DOM that React is managing in memory. As things change to the props that are being passed in, to the state that's available, the information, this render method will get re-executed. The results of executing that render method will then get diffed to the virtual DOM as it stands, and if something has been modified, then you will get a UI update. So I talk about things being immutable and that it really strives down the path of immutability. This is not there is no more obvious place of immutability in React than when you hit a form. So the problem with forms is they are mutable data. The whole concept of a form is mutability. You're entering data, you're changing something. So you actually have to explicitly opt into mutability on a form. You can put input elements on a screen, and if you don't subscribe to their onChanged event, so this is the JavaScript onChange event that's fired from a DOM element. If you don't subscribe to that, you actually will not get your key press recognized by React. It will reject that key press, and you will not see anything changed on the UI. That took me a while to catch when I first was using React, because I was like, I've got a value there. Why is there no value? I'm typing and there's nothing happening on the screen. It's because my onChange method, if I just collapse that method and come down a bit further. Sorry, what's it on set username? So when set username fires, I then update the state, which then tells React that that's cool. We can modify the value of this input property. Other things that I'm doing on here is I've got a button that's bound on screen that when you click that, you'll be logged in. And I'm just checking to make sure that you've provided a username. And if you've provided a username, we shell out to an external service that will perform the login. So this is very much a view concept. We don't have any real business logic in here. That's all taken care of inside of external services. Like any proper good application development, business logic pushes out to the business section of our application. So I'll jump through to our chat service. So this is a wraparound signaler that I've got for handling messages, and it just exposes me out a nice JavaScript class and programmatic interface, because I really don't like the fact that you have to rely on jQuery to use signaler. I try and hide that stuff away. I'll just come down to my login method. The login, login method. Yeah, sorry, that's the one I'm looking for. So the login just does some stuff like sets up the query string that SignalR is going to consume, calls connection start. So we start our SignalR connection, and then once where connection is started, we invoke the login, which then comes up here to logged in, and that will then invoke another method on this class, which we come back down, and then that notifies all the subscribers to wanting to know whether you've logged in, that something's happened, and then they can start dealing with state changes. So there's nothing explicitly in here that will modify state. It's up to the recipients that want to know about that. So going back to our login component, one of the first things I did in component did mount, I'll talk about that in a moment, is subscribe to the login and another event that can be fired. So component did mount is sort of a special method inside of React. It's got a couple of special methods. Component did mount and component did unmount are two of those. These actually remind me quite a bit of web forms, and that's probably going to not come across in the nicest possible way when I say that this reminds me of web forms. But there's a certain life cycle that that a React component goes through. So component did mount is when that component is actually being put on the screen. The constructor is, while it's called once when the component is put on screen, the ideal time that you want to actually do something before something happens to that component in terms of a display is component did mount. Because while you might have created an instance of that component, you might never actually put that on the screen. Because you can create instances of a component without rendering them. Component did mount is called by the React framework when it is about to display that. Inversely, component did unmount is when that element has been, that React component has been removed from the screen. And there isn't a concept of a destructor as far as I'm aware, because the reason component did unmount would be important is you might remove an element from screen because it's hidden, but you actually haven't disposed of it in memory because you want to add it back in later because there's just some conditional logic that's been hit. So once the user is logged in, we call an onLogin method, which is down a bit further. We update some state just to display an alert. Once that's updated, we then call out to another service, and then we navigate you back to the home page. This is the part of the demo where things might get a little bit hairy. Let me just jump back to my slides. Because, dear audience, there is a URL on screen that you will be able to navigate to. And when you navigate to that, you'll actually be able to start playing around with this chat application I've written. Be forewarned, I do have the Azure Management Portal open up in a tab on my other machine, and I can kill it at any time that I need to kill it. But for the sake of we're all good netizens, I'm going to let you go wild with my chat application. Also means that I can do some interesting demos. Cool, the video is just catching up on the other screen, so we'll start seeing stuff happening momentarily. So I've loaded the page. The first thing it's done is it's displayed me the login prompt because I'm currently not logged in. I'm going to log in and watch it spectacularly crash. No, it didn't. Hey! Richard beat me online. I knew I shouldn't have kept talking. So here we go. We have a chat application. I can see the number of users that are down the other side. I can say hello to people and put smiley faces. And what this is doing under the hood is this is modifying some, doing some SignalR calls back and forth. When that happens, we will be then sent information back to the UI, and we will update the state of what's on screen. Hey, we got more people connecting. Woo, video has synced up. Totes exciting. So let's just actually watch what's happening here. So I've got source maps turned on for the React components. So I can actually debug kind of the original code that I wrote rather than having to debug the really mangled code that has been generated from my minified files. So those reside inside my source, services, and let's jump into, actually no, we'll jump into, say, the home view. So I'm just going to up the font size of that a little bit. because even I can't read that, and I'm at this computer, so poor people that are trying to follow along on the video. So this component is, again, another React component, slightly more exciting. Hello, everyone that has joined. Exciting, isn't this? You can all talk to each other, because you couldn't do that previously in the other thing that we had for you to talk to each other. Yay! Yes, I got the Slice username. Other people can't get it. Yeah. Anyway, okay, back to my demo. So we have a constructor. We set up some state. So in this case, have some state that just says ready or not. That's for when you're connecting, or we show a message saying that whether you've connected yet or not. We have a collection of messages, and we have a collection of the users who are currently logged in. I'm going to wait and see if people work out all the fun quirks of the way that I've built this application. We'll see. So what do we do in this application? We have a component did mount again, because I want to set up some listeners to my chat server. So when I connect, I get a callback. When a message comes in, I have an on message received handler. I then tell the chat service to connect me using my current user, because I'm now logged in. That also means that if you refresh the page, you will reconnect. And then when a new user logs in, I get this update user list. That method is called. And this one, I'm modifying the state to update the list of users with everyone in the user service. So that's why our user list on the side here will be updating as new people open up new browser tabs and start connecting as many users as they want. Anyway, let's come down to, say, on message received. This is what happens when someone types in a message, and either I'm going to send a message or someone's going to beat me to it. I'm looking at you, Richard. Yeah, I haven't put in a kick command. Someone did. Someone sent a message before me. No. So let's just walk back up our call stack. Okay, so this came in from Signaler at some point. Yeah, down here you can see in our call stack that came in from Signaler. The message has been unpacked. We've hit this here. So I have a list of all the messages that have previously been entered. So there's been 21 messages that I have received so far. They're stored in an array here. I'm just going to grab those out. I add the new message that was received via the Signaler callback. That is actually in the object E, because this is a minified file. Hey, it was Slice2 who said something. So I add that message into our messages collection, and then I update the state by doing that. By doing the update state, I am then going to trigger the render method. Probably because now I've had 50 messages buffered, so it's going to be painful. So the render method is triggered because the state of this screen has changed. The information that React understands is not the same as it used to be. So something is different, and we can now continue on. So we come into here, our state is updated, and now we're going to use our render method. So here I am outputting a grid with some rows, some columns. One of those columns has a user list. The other is a message list. So this is a nested React component called message list, and I'm passing the messages through from the state as a property to the message list called messages. So if I open components, message list, put a breakpoint here, what we'll see is me hitting F8, and now this component has been updated, and it has properties. It has properties that has our collection of messages. I have obviously a whole bunch of threads that are running in the background that's updating the message list, that a whole bunch of callbacks that are executing simultaneously, and I'm causing them to operate in not quite the way that I want them to operate, but operate well enough. So the messages collection here is on props, so I can't change that. I couldn't add a new message inside of the message list and then expect it to re-render, because it's immutable data as far as React is concerned. So instead, what I'm doing is I'm going through each message here, and for each message, I'm creating another component called message, which comes into here. And if we hit F8, we'll end up inside of here. And again, we've passed the message as another prop. So, oh, that's right. I'm actually just rerunning it. So this is where it's interesting. So the messages collection, as you saw previously, had 23 messages in it. We'd previously shown the message from ANZ coders that had first, and that came in at that particular timestamp. That was already available. That had already been pushed to the screen. But it's still being passed through because we've passed through the whole messages collection here. But React knows that this particular message has previously been rendered. It's currently visible on screen. So I don't actually need to update it. So going through this particular render method won't change anything. I'll have nothing different to be rendered out. So nothing will happen to this DOM element. It will just kind of get skipped and move on to the next one, and so on and so forth until we basically hit the end of our array. I will just hit F8 and I will disable all of my breakpoints. All of my breakpoints. And see, yeah, there we go. So messages start like pushing themselves out. People are trying their best to break my application, but no, rock solid coding to its win. Is Richard going to kick me off? Because I think I'm pretty much close to time. And that's also, I think, a good lap around some of the core features about React. I can keep talking. If people want me to keep talking, I'm more than happy to do that. But the key things to take away from React is immutability. It really wants you to make sure that you are only pushing data down to the screen and in ways that it can't be changed. You don't have these monolithic components. So I've remembered building Angular applications where you have a single component that, a single controller that has like 50, 60 properties on it because they're all on scope and they're all things that will be modified on that screen. And a callback happens, like an AJAX request happens, and boom, the whole screen just refreshes because you've got so much data that's been modified inside of that. React really drives hard for this modularized approach that it, maybe because you're doing HTML inside of JavaScript or angle brackets inside of a rendering file, that it really does look quite offensive to have long files, and it encourages you to go a modular approach. And it's very easy to start passing immutable data here. So for example, this message, the messages item gets, messages component gets created. We pass the message through to it as a property. We also set a key on that. So React knows the key represents the unique identifier that React can track for that message, and it will know that this one, whether or not it actually has to do an update to this one versus the DOM element in its virtual DOM. The other thing, I hear Richard sucking and struggling to speak again.
Yes. The other thing, I was just going to say, we've got some questions if you want to run through those.
Yep, I'm more than happy to run through the questions instead of just blithering around on the screen. Hang on, I just have to bring up. Okay.
All right, so I'll do the first one for you just to get you started so you can find yourself. Have you shown everyone what you're doing to keep your voice moist, by the way?
Actually, yeah.
You'd have to stop screen sharing for that, but that's okay.
I'll stop screen sharing. We'll go back and look at Pretty Dancing Heads. Whoa, yep, that's probably worked. Okay, so to answer the first question, yes. Proper conference beverages right here.
All right, so do you always have your Windows taskbar at the top, or is that just for the presentation? Why is that the first question? I don't know, but it's been voted up too.
Yeah, wow, I'm impressed that one's the one that got voted up. Yes, this probably harks back to the days where I was using Linux systems and Mac. Just got used to having it up the top, and that's naturally where I now expect it to be.
Come on,
I don't
man.
like
You
it
should
on,
have said
I don't like it on the
Amiga
side.
OS, man. Amiga OS.
So hopefully that answers Stephen's question nicely. What is the memory overhead of maintaining a second DOM on large pages? That's a good question, and it's definitely something to be mindful of, Colin. Is it really that big an overhead? Thus far, the projects that I've worked on with React, we haven't noticed it being any worse than any other UI framework that we've worked with. The people that write React are a hell of a lot smarter than me when it comes to doing these things like virtual DOMs. So they understand how to do memory optimizations in this. They're probably doing a lot of tricks in that space. If you do some kind of nasty things, you can crash Chrome pretty frequently, but that's not really that hard to crash Chrome fairly frequently if you really want. Yeah, so to directly answer the question, haven't found it to be a problem. Does JSX get transpiled? And if so, what does the output look like? Yes, it gets transpiled. JSX isn't something that the browsers support. Oh, wow, I just realized that I have the chat on my laptop and I don't have to look at my Surface, which is on the table next to me. I can look at the screen. Crazy. Sorry. Yes, JSX does get transpiled. You don't have to React with JSX. It is really just a series of method calls. I don't have an unminified actually, no, I might have an unminified version. No, I don't. Sorry, to show you, but it does. It's basically a chain method syntax that it gets compiled down to. You can write it like that yourself. It's just a bit more verbose, and I find the JSX is actually really quite readable compared to the method call syntax. Did mount / unmount being removed from the screen? Did mount, did unmount, do they apply to visibility? No, they actually don't apply to visibility. They apply to whether or not the DOM element is in the DOM. So it's been mounted to the DOM or it's been unmounted from the DOM, because you can have an element that's in the screen and not actually visible. So it's display none or something like that. And that's still valid to have it on the screen. It's still valid to modify the contents of that element. So yeah, that won't cause unmount and mount to be triggered. And the final question, how does it compare to insert your favorite UI framework here? So I started with like jQuery and setting in HTML as that was my first UI framework. Eventually graduated to things like Knockout and then building on top of Knockout to do complex applications, to Angular. I haven't really done anything with Ember or Aurelia yet. Aurelia, from my understanding, is very similar to Angular, seeing as the guy who's writing it is former Angular and left after the Angular 2 thing. So my baseline comparison would be to Angular. How does it compare to Angular? You're not really doing a good compare and contrast, because Angular is an all-in-the-kitchen sink style approach. Like I said earlier, it gives you XHR, it gives you promises, it gives you a query engine, a whole bunch of stuff like that. It gives you even a way to design factories and services, and then have arguments about whether you're using factories versus services and stuff like that. So it's a lot more full-featured. React really has one thing that it's interested in doing, and one thing that it can do, and that is turn JavaScript objects into HTML and display them on screen. How you get that JavaScript object to the React component is entirely up to you. For example, the application we've just seen here, and I'll post the link to the GitHub project after the talk, is so we push that down via some call through signaler. We modify our JavaScript objects. I can see Richard basically dying on screen at the moment. It's kind of distracting. So we manipulate some JavaScript objects, push them down to the and then it's up to us how we convert those into the HTML that we want to render out. By using the callback pattern that I was there, and kind of a pub sub approach, I can actually write out the messages to two separate elements on screen without any kind of problems in that space. Whereas the project that a much larger project that I'm using it on, we've basically written our own XHR wrapper, because there isn't one out of the box with React. We've imported things like Q and Lodash because we want to be able to manipulate elements faster, stuff like that. So it really only cares how can you convert a JavaScript object to HTML, and it will take care of and the way you get that JavaScript object is entirely up to you. I've been given the finger to wrap up. And,
this
thank you, everyone.
not the other one. It's still a family-friendly show. Thank you, Aaron. That was fantastic. Okay, we've got to do the applause thing. We've got to do it, I think. Let's see. What applause should we do?
Applesauce.
We can do that one. Or actually, I can just go. And it's quite the same, really. Yeah. All right, thank you, Aaron. That was fantastic. Chat room, you know how to do the applause by now. Clap, 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 clap. The sound of virtual hands clapping. We are pretty much done with this session. Aaron will be staying in the chat room, I'm sure, just for a few more minutes, just while we do the switch over for the next session.
One of the two chat rooms.
Yeah, one of them. Grab yourself
Let's
a
see if
beer,
anyone can
relax.
work
It's
out how to
Friday
log
night.
out.
What? You can log
Let's see
out?
if anyone can work out how to log out from my chat application.
And Hannah wants to say thank you for attending this session. I don't know what she's... here she comes. Hang on.
After doing a bit of a costume change in my pajamas, thank you for attending this session!
Professionals.
All right.